So today I'm going to be talking about the top ways to hack your company still and how to defend against them. In case you haven't guessed by the title, I'm a penetration tester. I lead pen testing over at RiskPoint. I've been doing pen testing for a while along with network engineering and software development. So today I wanted to talk about a couple areas I picked out where I'm commonly getting wins against your environments, both application and network, along with why these areas are still prevalent. Nothing I'm going to talk about today is zero-day. It's, I'm sure, stuff all of you have already heard of. But why are these low-hanging fruit really persisting, and what tweaks have kind of happened to them that allow them to do so? So I'm going to start with application security, and when I was trying to figure out what kind of vulnerability to talk about first, I took a look back at a couple years worth of reports put together and looked at the high and critical vulnerabilities and just broke it down on what's the most prevalent we see out there. And above anything else, it's improper authorization, which I'm sure might not be a surprise to anyone. And this aligns with what we see from OWASP. So OWASP in 2021 upgraded what they call broken access control, same thing, up to number 1. So it's still a very prevalent and a very serious kind of issue. So just to give a quick kind of background, authentication is, hey, am I who I say I am? Authorization, which is more prevalently the issue, is, am I allowed to access what I'm trying to access? So why is it so hard to get authorization right? So I think there's a couple components that go into this. First, applications, without a doubt, have gotten more and more complex over the past couple years. This means more roles, more tenants, more routes, and kind of meshing and testing the matrix of all of those to make sure we have proper authorization checks and logic in each of those is really getting harder to do. We're needing more complex tests to do it. Also, I think that SAST and DAST scanners are really struggling to pick up on these authorization issues. Over the past several years, they've gotten really, really good and a lot better at picking up on things like cross-site scripting and SQL injection, but authorization is a lot harder and more nuanced because it's for one application, say, I can list all the users from a standard user role. Maybe that's okay for that application. For another type of application, that action could be catastrophic. But the scanner has no way of knowing what the truth of the matter is. So what are some of the defensive measures we can take a look at? And really, it comes down to, for a lot of these good cyber hygiene, this is where consistency is key. Auditing and testing every route, every role, every time. So making sure that we're consistently testing that whole matrix of authorization. Also, building the authorization as part of our dev culture, making sure that we're reviewing for it, looking at it in every kind of commit we make to the code, making sure that we have authorization focused on. I'm going to move on to exposed secrets. I'm kind of worrying through these. I know we only have 20 minutes and I'm keeping you from happy hour, so I wanted to make sure we cover a lot of ground in a short amount of time. So exposed secrets, we see a ton of. I'm sure you've all seen stories like this. Microsoft, Mercedes, an employee inadvertently commits to a public code base some proprietary code, some secrets, cloud credentials, API keys, what have you. Very common occurrence. Who's the enemy here? Well, of course, it's GitHub or whatever version control system you're using. Joke aside, here's a case found a couple months ago. This is a Fortune 500 company. This is in a public repo on the organization, and it's API key and secret and URL info for a API endpoint that allows you to reload payment cards, so think like gift card reloads and stuff. So as you can imagine, prime target for a threat actor. So how are we defending against this? Well, secret scanning tools have gotten a lot better, and there are some really good options out there. There's GitHubs. I know they have a feature built in with some of their packages. There's tools out there like GitGuardian, and on the open source side, we have Trufflehog, which is a really great tool. Should definitely be implementing some kind of secret scanning if you aren't already. But there's a kind of attack surface that's being missed and where we're getting some wins on, where we're able to get in on some of our clients. And I call it the shadow IT of secret exposure, and that's on personal GitHub accounts. So in this case, this was a client from a little bit ago. We had the employee of the client, their personal GitHub account, and they have a repository there called .files. For those of you that aren't familiar with .files, it's a way of kind of managing configs, developer configs, desktop configs, and moving them from one machine to another. And in this case, to make it nice and easy for everyone, he added the organization AWS keys to easily move to another machine. And that allowed us to escalate into their AWS account, and of course, you can imagine where from there. So this is something that our secret scanners aren't going to pick up on because it's not within our organization repos. So really, this is something that should be worked into your organization's threat models, saying, hey, we have employees, they have personal GitHub accounts, we need to consider that and consider it to be part of the attack surface and a potential room for exposure. So how can we defend against this? The personal GitHub accounts, some organizations out there, believe it or not, allow employees to commit off their personal accounts. That definitely recommend against. But even if you don't, understanding what your employees' personal accounts are and just scanning them, auditing, having that in your threat model. For the organizational GitHub accounts, another really common exposure we see is where the organization is scanned for secrets, but the individual accounts for that organization's employees aren't, and the employee inadvertently creates a public repo. So think Ben-Acme Corp, and I expose secrets through a repo on that account rather than my organization account. The other thing I'd mention here is don't neglect scanning and looking at GitHub gists as a source of exposure. For those of you who aren't familiar, it's a way to quickly share text documents a la Pastebin, but it's searchable and they're out there forever, and we've definitely seen a lot of exposure there, and it's kind of slept on in terms of considering where things can be compromised. I'm going to pivot now to what we're seeing on the network security side as common wins, and I would be remiss if I didn't start off with network poisoning and relaying. Think responder and LLM&R. So real quick, for a high level, network poisoning is where I have a client on the network, a user on the network, they say, hey, I'm looking for X file server, which doesn't exist or was an old thing decommissioned or a typo, and I, as the attacker, stand up and say, hey, I'm X file server, I'd love to give you all the files, I just need you to authenticate with me first. And out of that, in high level from Windows network, I will get the authentication in the form of a net NTLM v1, v2 hash. That hash can't really do too much with. I can try to crack it. Priori crack, maybe I get a win there, maybe not. So the next thing I'm going to turn to is relaying. Going back to that example with the file server, when the user says, hey, I'd like to authenticate with you, I take that authentication session and I turn to a resource on the network I'd like to get access to. So let's say the mail server. I say, hey, I'm going to take this authentication session and relay it over and say, I'm ready to authenticate, and just pass along the authentication. That's relaying. And for more info, there's a great blog post on it by Byte Leader, and as you can see on the date, it's 2017, so 7 years later, and still very effective. Now, how effective, you're wondering? In 85% of enterprise network penetration tests we performed over the past 2 years, we gained access to privileged accounts using these poisoning and relaying techniques. So even still, we've known about it for decades, the idea of poisoning, and still just as effective as ever on enterprise networks. So what are some of the initial mechanisms of defense we might put in place to kind of help this out? Let's say we go in and disable NetBIOS name service, we disable LLM&R, which are two of the common protocols we poison, and then let's say we take relaying off the table. So we disable SMB v1, we enable SMB signing, and then also take LDAP relaying off the table with LDAP signing and channel binding. As an attacker, the first thing I'm going to do is I'm going to switch protocols that I'm poisoning. So instead of going after NetBIOS and LLM&R, I'm going to go over to MDNS, ARP, DHCP. Now, with relaying off the table, we said that we don't get to go over to a new service. We get that net NTLM hash that we can't authenticate with. What we really want out of that is the NTLM hash. That's something we can go and authenticate with services with through pass the hash as good as the password. So the next kind of attack I'm turning to is one that is slept on a little bit. It's called a hash shucking or password shucking. To describe this one, we need to first understand what goes into a net NTLM v2 hash. That's the type of hash I'm capturing from poisoning. At a very simplified level, there's a little bit more that goes into it, but roughly it's the base NTLM hash plus a client and server challenge, and then that's hashed again to create the net NTLM v2 hash. The idea of hash shucking is I'm trying to recover that base NTLM hash. So I'm taking the net NTLM v2 hash I captured along with the client and server challenges, and I'm trying to hold list of candidate NTLM hashes, slotting them in there, seeing which one fits to create the net NTLM v2 hash. If I do that successfully, I've recovered the NTLM hash that I can then go and use to authenticate with services. For reference, there's the kind of hashcat command to do this kind of attack. We've found great success with doing this, recovering those NTLM hashes on networks that have put in some of the safeguards, and that's a way we're still getting wins even when we're starting to see some defenses go into poisoning and relaying. One quick note, where do we get that giant list of candidate hashes, NTLM hashes? It just happens that Have I Been Pwned, the site that collects all the breach data, puts out a huge list of all of their passwords in NTLM format. So definitely a good resource there. So what can we do in terms of defense? What defense mechanisms can we put out there? Well, like we mentioned, we can disable LLM&R, NetBIOS, SMB signing. We can enable and disable SMB v1, the LDAP signing as well. We can block DHCP v6 and router advertisement in Windows Firewall. That is another kind of protocol we look to poison. For WPAD, which is a common attack path, disable it, or if you're using it manually, specify the path, no auto discovery there. And then kind of the gold standard is to take the NTLM problem away entirely, migrate away from NTLM to something like Kerberos. So the next thing for network I wanted to touch on, another area we're getting into your company through, is through LSA secrets. Now, what are LSA secrets? It's a place in Windows registry where Windows stores domain credentials, service credentials, keys, website logins to use. And it's not uncommon. On our tests, we found domain administrator credentials stored in these secrets. Why am I talking about LSA secrets? I'm sure a lot of you have probably heard of Mimikatz and LSAS memory attacking, which is where I'm dumping the memory of the LSAS process and recovering credentials in memory. And really that comes down to, with how prevalent Mimikatz and the LSAS memory attacks have been, both through pen testers and through threat actors themselves, it's been an area that's really been monitored and started to be hardened by EDR. EDR, if you touch any kind of memory or try to dump the LSAS process at all in any way, EDR flags on it, tries to block it immediately. Of course, there's ways to bypass that. There's EDR unhooking, EDR bypasses, but LSAS, in our experience, and we've seen a lot of big brand EDRs, it rarely, if ever, flags on this and blocks that attack path. So I think there's certainly room for improvement in terms of the monitoring for accessing these secrets. So to that point, what are some defensive measures we can look at? So this is back to that good cyber hygiene stuff, the regular password changes and complexity. By rotating those passwords, we're reducing the lifespan of those secrets stored in the LSAS, or in the LSA memory. So if an attacker gets them, hopefully they've been expired by that point. There's also applying the least privilege principle. So making sure that domain administrators are using regular accounts for their day-to-day and only using those privileged accounts for specific administration functions, just reducing the spread and exposure of those accounts in general. And then finally, of course, increased login and visibility, specifically relating to the LSA secret store. So I know I went through just a whirlwind of, and I'm sure there's 100 kind of findings we could add to this, but this was just in the past couple years, the findings that we feel have been really prevalent despite being known for years and years and years, and we haven't seen much improvement in defending against them, or slight tweaks make them still relevant. So I know I'm keeping everyone from the happy hour, so I'll end there, but happy to take any questions either now or afterwards. Thank you so much for your time. Yes?
You mentioned password rotation, but you didn't call it a 2FA. Have you had success against two-factor authentication attacks where people actually set up for Windows?
So I will be very candid. Okay. I think in the hundreds of network engagement I've seen, maybe one of them have had MFA enabled network side on their Windows AD environment. I think it certainly can be a very effective tool. I have almost never seen it actually implemented.
Understood. Thank you.
Great question. Any other questions? Awesome. Well, thank you very much.